All right, so this is just a little wrap up of Monday's lesson on limits to infinity. And as we saw, we have x headed to infinity, and if it is a rational function, 1 over x, the limit is 0. And if it heads to negative infinity, 1 over x is also 0. And the way you can think about this, as the x values increase, the y values end up getting smaller and smaller, so it approaches 0. And when x approaches negative infinity, the x values decrease, like heading negative, negative. The x values would decrease and the y values would get smaller and smaller, which means it also approaches 0. So now, let's look at these examples again. What the technique to do is to divide all terms by the denominator's highest power of x. So we have this little definition here. So what we are going to do is identify the highest power, and we're going to divide each term by that. So in this particular problem, you will notice that x is to the power of 1, which is the highest. So we are going to take the limit as x heads to infinity, and we're going to have 5x over x plus 2 over x. See, we are dividing every term by that, that's a minus, by that highest exponent. So again, we've talked about this. X over x goes to 1, goes to 1. So we are left with the 5 and the 4. 5 plus the 2 over x, 4 minus 1 over x. Now, if we think of the limit of these, we know, even if it's, the constant doesn't matter. So as when we have this and this one, they go to 0. So we would have 5 plus 0, 4 plus 0, and our answer would be 5 over 4. Problem number 2. If you notice, the highest exponent or power is going to be that x squared. So we are taking every term and dividing by the x squared. So each of these in the numerator are divided by x squared, and each term in the denominator are divided by x squared. So if you notice, when we simplify that, this simplifies down to just an x in the denominator. This goes to 1. So now what we have, let's rewrite this. We have 2 over x plus 3 over x squared, 5 plus 1 over x squared. Now, when you think about these limits, the limit of that one, and that one, they are all 0. So really what we're left with is 0 plus 0 over 5 plus 0, which is 0. So the limit as it heads to infinity would be 0 of that particular rational function. So taking a look at example 3, we have the highest power, in this case, is going to be the squared. So what we have, I actually wanted that to be a highlighter, so let's try that again. So we are dividing each term by the x squared. Each term in the numerator, and then each term in the denominator. So what you always have to make sure you're careful of, everybody, is to realize what separates the numerator and the denominator. And if you want, you could just probably draw that a little bigger, or maybe change the color to realize that's where the fraction line is. So what happens? That goes to 1. This goes to 1. This goes to an x squared, an x in the denominator. This does the same thing. And here's what we have. Let's go ahead and write this out. So we would have a 2 plus a 3 over x minus a 4 over x squared, a 6 minus a 5 over x plus 7 over x squared. So what we end up with, this is 0, this is 0, this is 0, this is 0. When we talk about those limits, when we have that rational function with the x or the power of x in the denominator, so what we are left with is 2/6, which is really 1/3. Okay, number 4. So again, we are looking at the highest power. So we're going to divide every term by x squared. So we have x cubed divided by x squared minus 2x squared divided by x squared plus 7 over x squared, 5x squared divided by x squared, and minus 3x divided by x squared. So what happens is we have to again see what we can simplify. This right here ends up being an x in the numerator. That goes to 1. The 7x squared stays the same. The x squared over x squared goes to 1. This one is left with just one exponent, or x to the 1 in the denominator. So what we have x minus 2 plus 7x squared over 5 minus 3x, 3 over x. So now we got to think about what happens when we're taking the limits. This goes to 0 and that goes to 0. So we are actually left with a function that has x minus 2 over 5. So now when we think about this, as x is heading to infinity, this number is, the x is going to get big and big and big and big, and the minus 2 over 5 really does not come into play. So our solution is, as the x gets big and big and big, it's infinity. All right, let's take a look at the next page. And we are just going to look at, we're not going to look at these. We are going to look at these other 4 examples. Now, we have to talk about different functions and what we call the dominant functions, or we can say the most impact on our limit as x goes to infinity. So the first one is exponential, e to the x. The next one are the powers, which we just did. And the last is log. Now, here's what I want you to realize. When we are talking about exponential, if you recall, that graph means that it's growing and growing and heading to infinity. So what we would have in this particular number 1, as we have e to the x in the numerator, that's going to keep getting big and big and big and big. So this is infinity. Number 2 is doing our powers again. So we would have, let's just go ahead and do one of these. We already practiced some of these. So we have x is going to infinity. We are dividing by the x squared minus the 8x squared. Let me go ahead and erase that so you guys can see that it is x squared over 2x squared divided by x squared plus 1 over x squared. So what's going to happen? We are going to end up with these simplifying. This gives us an x in the denominator. That goes to 1. The others stay the same. So we would have we would have 4 over x minus 8 over x squared over 2 plus 1 over x squared. So now if you notice, what happens? This goes to 0, this goes to 0, this goes to 0 because of our rule, and we are left with 0 plus 0. Let's write that again. 0 plus 0 over 2, which is 0. So number 3. Again, this is a power one. And these are what we just practiced up above. So what are we doing here? We're dividing by an x squared. So let's go ahead and do that. Each one divided by x squared. And plus 7 over x squared. So again, we're simplifying. Goes to 1. This ends up being 1 over x. Goes to 1. This ends up being 2 over x. And we have negative 3 plus 1 over x minus 5 over x squared. 5 plus 2 over x plus 7 over x squared. So now I believe you'll recognize goes to 0, goes to 0, goes to 0, goes to 0. We have negative 3/5. All right, on to our last example. So again, this is a power one, and our largest power, or highest power in the denominator is the x squared. So we are, again, dividing every term by the x squared. So when we simplify this out, this ends up being a 3. This ends up being a 4x to the 1. The 6 does not change. That goes to 1. This ends up being just an x in the denominator. So what are we left with? We're left with an x cubed minus a 4x plus a 6x squared over 5 minus 9 over x. So now, here's what I want you to think about. In the denominator, this does go to 0. But now when you think about it, as we are heading to infinity, all of this is going to end up getting larger and larger. I see a little something I didn't do right, you guys. This should be 6 over x squared. So then, these are just going to get bigger and bigger and bigger as x heads to infinity. So your limit is infinity. All right, that's a wrap up of Monday's lesson. See you next time.